just like any other term, even if I have a complex, what looks like a monomial sitting in front, I can distribute just like anything else. Negative 4i times 3 is negative 12i. Negative 4i times 5i is a positive times a negative is a negative 20i squared. Remember what I squared is. I squared is negative 1. Negative 1 times 20 is positive 20. Once again, whenever I see that I squared, what it's going to do is change the sign of the coefficient. Well, what if I have 1 plus 2i times 4 plus 3i? What I would want to do here is, just like it looks like with two binomials, let's FOIL it on out and see what happens. 1 times 4 is 4. 1 times 3i is 3i. 2 times 4 is 8i. 2i times 3i is 6i squared, but we got a lot more going on here. We got like terms we can combine. There's an 11i. We have an I squared, which is negative 1, making that negative 6. But if I have a negative 6 and a 4, that ends up with negative 2 plus 11i. Now notice the form a plus bi. The form a plus bi. My answer, the form a plus bi. These are closed over multiplication. I will never have an I squared in one of these answers. I squared is that negative 1. And when I multiply it, all it's going to do is change that sign, combine it with any other constants. Even back here, a plus bi was the form. This wasn't the form a plus bi. My a just happened to be 0. It's that hidden 0 that we don't have to recognize until it becomes important. Even my answer, whether it's even in the form bi plus a, there is no order of descending power. So by changing the order, as long as we're careful with our signs and matching up the numbers, we're still totally fine.